from the actual video also. So actually they're probably better than the video. Do you guys have any questions from any of the homeworks that we want to look at first
Yes.
of all? Okay.
Yeah, let me pull mine up really quick.
Yeah, me too. Let me pull mine up too and we'll look at it.
I started 3.2 today and I asked a question about it in the sit session I went to right before this.
Yeah.
And oh my Lord, it was just intense. It was long division and I'd never seen anything like it before, so.
Okay, yeah. And those are the notes that I placed on, they're in Canvas already. Those notes are, and I believe, I think I just posted the first part of the video. It hadn't uploaded totally yet, so I'm hesitant in saying it's there.
Oh, you know what? No, it wasn't 3.2 I started today and it wasn't too intimidating. It was 3.3 he was talking about in sit today.
I haven't looked at that yet.
Yeah, 3.3 definitely is, it is different, but I think if you'll listen to the video of it, I think it'll help you through the, it's going to seem kind of weird because you're dividing using variables, and I'll be more than happy to share one of those with y'all today even, that's fine. But don't make too much of it. And I've tried to color code things and talk you through what I do, but I'll be more than happy to show you one live today too. Were there any questions in 3.1 and 3.2 that y'all wanted to look at?
Could you just take us through, because it's just still kind of unfamiliar to me, take us through number 2 on the 3.2 homework.
Okay, let me look at it real quick. Have y'all had much trouble with y'all's internet?
Mine's been slow.
Mine's buffering all the time.
I think it's because everyone in the world is
right. Yeah. I know. I wanted to tell one of my friends' aunts was on there saying, "Oh, we had such a good yoga lesson, blah blah blah." Get off of it. You don't use Zoom for yoga. Get off. So I'm like, dude, no wonder we're running down here. Okay, so let me share with you a screen. Now my numbers may be different, but it'll definitely be okay though. And let me, okay. I turned off my video so that I wouldn't be showing my ceiling every time I have to move my iPad around. So on this one here, on number 2 in 3.2 is the one we're looking at. 3.2. And the question is, what's your end behavior of the graph? And so when they talk about end behavior of graph, just in general, so like, let's say we have a graph that looks something like this. That's a bad looking arrow there, but what we're talking about is, as if you and I were looking at where this arrow is headed, okay? So as you and I go further and further out this way, then we notice that the graph is headed towards infinity. So that's what we're talking about, behavior, okay? We're gonna notice here that this arrow is pointing down, definitely, but when is it happening? As we're coming from negative infinity. So that's what we mean by behavior. So your eyeball is going to have to look up and down. It's also going to have to look left and right at the same time. So this one's kind of, it doesn't really write it in English, unfortunately. And so he's asking you, before we get to the actual problem, he says, as x approaches negative infinity. Okay, so right there, what we need to realize is what he's asking you. So in words, right, because that would be easier. In words, he's saying, as you travel to the left. Okay, so as you and I travel to the left on the x-axis, And I know that because he's saying that x is going to negative infinity. So you and I are looking at, let's just say we pick a point somewhere in the graph, somewhere like right in here, and you and I are watching the graph as we go towards negative infinity. What we're going to look at is at the end of that graph. So on the left-hand side of that graph, it looks like the graph is going down, right? And so you and I would say graph is going down. That's kind of how we would talk to each other.
Mm-hmm.
Now, in mathematics, though, we can't really use these words necessarily. And so what we say is, we say, well, he called this graph H. So H of X, which means this is going to be your arrow, okay, of the function. And we're looking on the left side because this means go to your left. So on the left side of the graph, the function or the arrow is actually going down, we said, and down implies that you're going to negative infinity. So as your graph went further to the left, this graph went down further, further, further on my picture, just on my picture here, okay? If it is said as x goes to, and sometimes you'll see them write the little plus sign in front of infinity just to make sure you understand you're now going to the right. But as you and I approach now infinity on the x-axis, what this tells me is now try to go look at your graph. Okay, so I'll put it in words. As you travel to the right, again on the x-axis, graph is doing what? Here he was wiggling, right? He's wiggling. And then as we're getting further and further on the x-axis, what's it going to do? What's it look like it's going to do?
Go up.
Yeah, it's going to go up. Okay, so if the graph is going to go up, then that means that the name of your function, which happens to be, in our case, h of x, we saw him also go up. And this is how we write up, positive infinity. So remember in the old days how this h of x right here was just real fancy for y? So what they're saying is as the x's go to the right, then the y's are going up. So this is going to be an up positive infinity. This one is to the right positive infinity. And the only way I know up from right is the variable that they're using here. As x goes to infinity, that means to the right. H of x, which is also known as y, well, y goes up and down. So if I go to positive infinity, I go up, okay? So these are kind of like the motions that it's taking, but we use the result of infinity or negative infinity to help us. Does that kind of help a little bit?
Yes, quick question.
Sure.
The way he kind of talked about it and sit was like looking at the hold on, I have it in my notes. Looking
Sure.
at the first degree or the highest degree, and then looking at the a term to kind of determine the same thing. Is that?
Absolutely right. Okay. So if you see the thing that we have to our advantage is we can go type this into our graphing calculator right now.
Mm-hmm.
And then if we can get a visual of what this graph is doing, then we can also double check our work. So here, if we didn't have a graphing calculator, or if we asked you why is it doing what it's doing, whoa, hello, come back. Hold on just a second. Sorry about that. I'll be back. All right, so as we're looking at this right here then, the leading term is the guy who basically runs the show here. And so 14x to the fifth is who we're looking at. The rest of it is kind of like fluff. That's where the wiggles happen. And so this first term right here, our a value is 14. And since this value is bigger than 0, then he describes what the right arm is going to do. Okay, so if a is bigger than 0, then your right arm goes up. That's an automatic. Okay.
I'm losing you at the bottom there. Is there a way to?
Yes.
Oh, no, I got it. Never mind.
You got it? Okay. Awesome. I'll write up a little bit higher this next time. Now, the other thing that we're looking at is, let me get a different color. Okay. The other thing we're looking at is your degree. And the degree of a polynomial is always in the leading term if you've got it written in descending form. And so this one's descending because you have 5 power, 4 power, 3 power, 1 power, and no power. So we're set up just fine. So they call this the n value. N is 5. The number 5 here is odd. And since you have an odd number, then this forces arms to go in opposite direction. And so right here, we've already nailed down what the right arm was going to do. If the right arm goes up, then the other arm, which would have to be the left arm, if he's going to go in an opposite direction, he'd have to go down. So we called it the leading term test, basically. That's kind of what allows you to figure out the behavior of your graph. It's just the way they write it on here for number 2, like how am I supposed to respond? If we don't realize that this information right here, right arm means as x goes to infinity. That's where your right arm is always going to be because it's to the right of the graph. Then we would not have known that it was talking about this right arm, okay? So that's the only thing you got to be careful of. I would definitely be looking at the graph. And then when someone says your left arm, well, the left arm is to the left of the graph. And so here we would have to say, am I too low down here now? Yep, it looks like I'm going to be. Don't do everything. There we go. Come on. If I were to, let me come right up here. So for left arm, that means as x approaches negative infinity, so you're going to the left of the graph. If I say my graph is going up, then that means whatever his name is. We said that his arm's going to go down, so that's to negative infinity. All right, so to me, it's more of the cryptic language that we write things in. Compared to the, when we speak about it, we can talk left, right, up, and down pretty easily. Well, left and right are going to refer to the x is going to negative infinity. That's left. X goes to positive infinity. That's right. And then h of x for a polynomial, you only have 2 choices. Since it's smooth and continuous, either the right and left arm are going to go up, or the right and left arm are going to go down, or they're going to be one of each. So the only thing that would fill in the blanks right here are negative infinity and positive infinity. Does that help a little bit with the language?
Yes.
A little bit, yeah.
Okay. So knowing that leading term test certainly will help. Like I said, the rest of the terms in that polynomial just kind of give us the wiggles. The only really benefactor here is that at h of x, at the very end of his function, he has the number 7 without a variable, and that's the y-intercept. When you have a polynomial written in term form, the constant's always the y-intercept. That's about the only other thing that he helps us with. Now, I'll post this Zoom meeting for us, and so it's going to have everything that I wrote on here for you, okay? Because if we go to another question that you might have, then I'll need to clear the screen for us.
Is there
any more? Go ahead.
Is there ever going to be a time where, like, it's not going to specify right or left arm, and we're going to have to know, I don't know, algebraically, like what it's talking about?
If you look at problem number 2, the way that that's described that way, that's what we mean by the mathematical way to write it's going left or it's going right. So knowing that x means left or right on the axis, negative infinity on the x-axis is always going to be on the left side. And
Oh, I'm sorry, I used the wrong
Okay.
language. I meant
No
like
problem.
the right or left arm. If it's,
Okay.
are we gonna ever be asked what the right or arm is doing without it saying the right arm?
Basically, this is actually referring to the actual arm itself. Yeah. Because
Okay.
if you go to the left on a graph, like I said, just kind of, I would center myself somewhere just so I know, okay, what do they mean by left? And so as I travel to the left over here, that just means you're traveling this way. So you're to the left of the graph. You're looking at what does his arm do. So this is the left. And then when you look at the arrow for the arm, then that's what we mean by X is going to negative infinity. That's what we mean.
Okay, yeah, I got you. Thank you.
Okay, so you'll either see in English, they'll ask you, what's your left arm behavior? Like they might write it this way, or they may just say this statement as X was approaching negative infinity, and then you tell them. So we have to know that left arm behavior is also written as X approaches negative infinity. They're synonymous with each other.
Okay.
Okay. What other questions?
I tried to go on the Microsoft Stream on the video notes, but when I tried to pull them up, it said that the content had been removed. Is that something just on my end?
Probably. Can you tell me how you got to there?
Yes.
Okay.
Let me maybe start a video. 1 second. Let me get to my computer. Okay. So, 1 second. Let me reverse this. Let me see how to. Okay. So I'm on here. I go to modules. Okay. See, I'm trying to remember where I go from here. Test 3.
Yeah, if you go to module test 3.
Yeah. So video lecture 3.1. Yeah, this video cannot be found.
So let me find where.
I was having that same issue. That's why earlier I was saying I just went straight to stream and searched your name.
Yeah, I think I would go straight to, yeah, it sounds like almost that's going to be, because every time now that when I went straight to the stream app and select people, then type in my name and just put Sally space Haas, then I'm coming straight up. All of my videos are.
Okay, so
See if you can try, try that with us and see if that works.
Okay, so under discover or search?
Search.
Okay, so, search name. I got it. Sally
do people.
Haas.
Yeah, do people and it'll come
People?
up better because, yeah, what it'll do is it'll do like every Google does. If you just say, find me Sally, well, then everything that has a Sally in it's going to pop up. You don't want everything.
Okay, so am I in the right part? I'm doing sort by name. You haven't come up yet. How do I get to people?
Up where you chose name, there should be a people. Do you not have it?
No.
Ooh. Okay. Hold on.
Okay.
Oh, okay, my bad. Go to search. I'm sorry. We had you go to discover. Go to search first.
Oh.
From the stream app. Okay. Okay, and now it says videos, channels, people, or groups. So go to people.
Okay,
Are you
so
seeing that? Okay.
yeah, so up there. Okay, people. I see you.
Uh-huh.
Okay,
And,
gotcha.
and you
Okay,
got me now?
yes, thank
Okay.
you.
Sure, sure. And what I'll try to do too is, since they're all just kind of listed there, I should be able to go in there and put them into folders for us. And so I'll try to do that or get it a little bit more organized so you don't have to figure out which one's which.
Okay.
I'll try to make sure I didn't even think about once they left my website or once they left Canvas that you would need to know. I don't think at any time y'all are doing the same section number as someone else though. So I think we're safe, but I'll try to go in there and at least put the titles of them.
Okay, thank you.
Okay. Sure.
And I have another question.
Sure.
Do you cover within the stream questions like 13C? I'll try and get an example up 1 second.
Okay.
Where it's like downward stream, this kind.
I don't think I spoke to anything like that. Where did this one come from?
It covers it a little bit in the textbook, but it wasn't super helpful.
Which section are you on?
3.1.
Okay. Let me catch up with you real quick.
Mm-hmm.
And what number is that one?
13C.
13. Okay.
And in the textbook, it's exercise 46.
Okay. Okay, so in this problem here, in 3.1, we're studying the quadratic function. And the main thing here is to show you how we can apply what we know from the vertex, if it acts as a max or a min. How do you know if the graph's going to go up or down? And so in that first part there that you've got, they tell you the story of how they got this formula. We pretty much don't care because since they've given us the function, we just run from there. The one thing you want to care about with the function is knowing that H stands for height of the water, and it's also in meters, and then that X is the distance away from the firefighter to the building. Okay, so in question number 1, they ask you to go through in there and just find what our value is. Let me just type something in here so I can get it to move for me. Okay. All right, let me get down to part B, or the second part there is asking you to find the maximum height of the water. So when you hear words like max and min, if you're given a quadratic, you know that has to be the vertex. And this is where it was important to know that H is the height of the water, which is the Y value, and X is going to be the distance from the firefighter to the building. That's what's the important thing there. I'm trying to get to our third part here that you're asking about. Okay. The flow of water hits the house on the downward branch of the parabola at a height of 6 meters. Okay. This is like the problem that I did in the video for 3.2 or 3.1, where we had a football player. Remember the football player? And the quarterback has passed the ball to him. And of course, when you pass the ball to someone else, they're not catching it on the ground. They're catching it right there, kind of like in their gut. And so what they've said is that's about 3 feet off the ground where our guy actually catches it. So that's the height of the ball. Well, in our case, this is water. So where the water is hitting the house there is at 6 meters. So 6 is actually representing the H value. And so then we're going to set this function equal to 6 and then go and solve it. Now, one of the things that kind of tips me off, where the question says the firefighter is approximately, which means you and I know how to take the quadratic formula and find the answer. You do not have to simplify that at all. You can literally type that into your calculator and get the decimal approximation for me. Okay, because I was kind of looking at the the work there that was shown, you need to
Mhm.
set up the quadratic formula. Absolutely. One of
Mhm.
the answers is going to make sense and the other one's not going to make sense at all.
Mhm.
So is that what you're kind of talking about, or?
Mostly, I think I'm gonna watch the video now that
Okay.
I know where it is.
Okay. Basically, like I said, let me see if I can get you here. Basically, since we know that, let's say here's the building, here's the firefighter, here's the water, it's going to hit here at 6 meters.
Mhm.
Okay, so this is your function that you're following, and we want to know, when is this function going to equal to 6? And so as you plug that in, I mean, you can tell that these numbers are disgusting.
Mhm.
I mean, I'm glad someone gave it to us though, but okay. So this just says the height of the water, that's his function, is equal to 6. That's all that says. And so now, in order to do the quadratic formula, we know to go ahead and get this guy equal to 0. So by subtracting 6 from both sides, I'd have a -2 now. And then here's your ABCs. So your C is -2, here's your B value, here's your A value. And what I meant by, I mean, I don't think I would spend a lot of time simplifying this, because this, like I said, it's going to be kind of ugly. I would need to at least put it like what I had here. We know how it's going to work. 4 times A, that's a -029, and then C. And then all of that's over 2A. Okay, so now what I would do on my calculator, if you're not sure if it should be the plus or the minus, then you need to do both of them. Some of you will be able to rationalize this out, but in my calculator, I would use my template for my fraction if I had it. And I would put in what happens if I add, you know, the root and then divide. So like, it's different from when we're calculating and we want an exact answer. When we want an exact answer, you and I have to actually calculate this underneath the radicand and take out whatever perfect square. You're not doing that. Okay. And so you'll get this answer. Now, if this answer is negative, then that's going to be kind of stupid, because this says X is measuring how far are you away from the building. Okay, how far away from the building. So if X ends up being negative, then that's dumb. Okay, so then what you would do is you would, and I'll be honest with you, I'm extremely lazy. So I would go back to my graphing calculator, move my up arrow so that this is highlighted now, bring him back in, and I would change then to minus the root over this. Okay. And then see if this is minus or plus. Now, if they're both minuses, something's wrong. Okay, something's wrong with your work. One of these has to be minus, one has to be plus. I think actually this top one's going to be the positive one. But you don't want distance to ever be negative. So that's how you know which one of the two answers to pick.
Okay.
Okay.
I'm still very confused. Sorry if this is a stupid
No.
question, but like, so X is the vertex, correct? Here?
Well, to be honest, we really don't know where I mean, we can calculate where the vertex is. We don't really know where the vertex is until you go and calculate it. But in our case here, what this is doing is, if you and I were to go and graph this, okay, then what used to be called the x-axis is still called x according to this problem here. But what I have to know here, this is distance from building to firefighter, because that's what it said in the problem.
Oh, okay, so it's just X as a variable?
Yes.
Okay.
And then this you better?
Yeah. Okay.
And
that
then
makes so much more sense.
There you go. Y is really H, which actually means it's the height of the water. So as we watch, like I said, I really don't know what this guy looks like, except for I know he starts up here at 4 and he goes up like this at some point somewhere. That's what he does. So what happens when you start to solve this equation is you find out that up here at 6, you have a possibility of hitting the parabola here and here. Well, it just depends upon where the building is. If the building's right there at your face, I mean, okay, more than likely that's not the answer, though. More than likely it's going to be this one over here. Okay, but yeah, the vertex, whenever you do find it, he's actually going to be telling us the distance from the building to the firefighter, comma, the height of the water. That's what the vertex is going to represent. You really want to change those axes. The minute you see this business right here equals Lala, then you get in there and you start telling yourself, okay, X is now really representing what? And what is this H really representing? And so that's the first thing I'll do. I'll just kind of mock me up some X and Y axis here. And I'll write in words if I have to keep it straight for me. Sure.
Okay.
Okay. Yeah, that's a great question, because everybody can kind of like plug these numbers in. That's not really the issue. It's now deciphering what did you just find out. Okay. Yeah, that's a great question. Yeah.
Dr. Haas?
Thank you.
You bet. Yes, sir.
I've been refreshing the videos this whole time and they finally worked, but it's weird because I've been doing this since like Friday, so I don't know why it took so long for them to pop up.
Yeah, there's no telling. There's absolutely
Yeah, like
in pre-cal
I googled your name.
Okay. Oh,
and
and
that's
then
what
it came up?
and then it came
how
out.
funny.
Yeah.
How funny. Yeah, no, in pre-cal I had to like split. Their lecture was very long, and so I split it up into 6 mini videos, and 4 of them were fine and 2 of them weren't. And so 2 of them, they have to go out to stream and get them. The other 4 are linked perfectly in Canvas. I think
weird.
Canvas is just so freaking overwhelmed right now.
It is.
And I swear to you, I'm doing the same thing to every one of the videos I take in all of my classes. And some of them are fine and some of them aren't.
I don't know why they didn't let y'all do it through YouTube, because YouTube can handle that kind of upload. That's
true too. And it may be where I just hate to keep changing things on y'all. Like we learned something else Friday night. We had a 2-hour meeting and we learned something else, which would be kind of cool too. But I'm like, dadgum, I don't want to change everything for my students. I'm afraid to.
I know, but YouTube is so much because YouTube can handle the huge upload. I mean, for now it's working. I'm glad it works, but like I literally, I kept clicking in from the
link,
from dashboard, and it wasn't working. Then I somehow clicked on the second video, and it finally worked. And then I went into the stream and I searched you, and then it popped all your videos. But I've literally, and now it's giving me a server encountered error, and now they erased again. So this is not my email, is the stream.
Gotcha. Okay.
So I popped the 3 videos, at least the lectures that you've already had out. So I can see those, but I can't see the other mini lectures anymore. Does that make sense?
Yeah. Okay. Well, it may be where it may be where this weekend I've got to just go in there and move to YouTube then. I may just have to do it.
And I see, and now I can't even watch the videos that I had. Now they're gone again. I literally had them, and now they're gone.
That's weird.
Yeah. So this is okay.
All right. Well, I'll keep trying to go through that way, I guess, if you can.
I will. Yeah. I'm not gonna stop doing it, but I'm just letting you know that I've been trying this since Friday. I'm just home every day, so I'm not doing anything. I'm in my office all day long. So
absolutely.
So yeah.
Okay. Yeah, I'll definitely go back and I'll see if there's some alternatives too that I can throw them to real quick.
Or maybe can you, and I don't even know if you can even do this. It would be too long, like to drop it like in a Google Drive file.
Yeah, I can do that.
And then I can just get it from a Google Drive. You can like add it on a drive with my email, attach it, and then I'm just trying to think, because I know people have it, but like I can't do any homework. I'm dumb as a rock when it comes to math. So without this, I'm like literally just sitting on my thumbs, my hands, doing nothing.
Okay. Yeah, let me see what I can come up with then. And I'll look for some alternative that'll work for everybody too.
Okay.
Out of curiosity, what was that thing? You said you had a 2-hour meeting and y'all learned something new?
Yeah, we actually had 4 separate meetings within the 2-hour meeting. And so each one of them dealt with a different type of, I guess, different way to introduce a lesson, or to, like one of them was using Notebook. Have you ever heard of Notebook?
Yeah.
Notebook is a way where you can house all of you can actually write on the lessons themselves too, but I can go in there and upload videos. So that's one area. There was another one where, of course, we went back over like Stream and things like that. We went over Canvas. There's also another way to go through Canvas now, where you go through the student end of it. Then I upload things on the teacher end of it, and then we go back into the student end of it. So it's a little more time consuming, but it could possibly work. So I'm thinking that I may try to utilize Canvas a little bit more, but I don't know if he's already having trouble with Stream. I don't know. I've kept all of my Zooms, so I can always like try to start over. And I hate to load up the Zoom link, but I may just have to go straight back to that again. We weren't having any difficulty with the Zoom links.
Yeah, you were setting those nice.
Yeah, so I may just have to go back and do that again. So anyway.
I'm sorry, I'm not trying to be complicated. I apologize.
Oh, no. The frustration part of it is the time it takes to actually make the videos, wait on them to be downloaded, and then to get them uploaded. And so it's frustration only simply because if my students aren't getting a chance to look at them, then frick, why am I spending all this time doing this? So, yeah, I just need to find a better way to disseminate them to you. So. Okay, so if something, something will happen. I will change, and I will send you an announcement when things are up. And what I need from you guys, if a couple of you don't mind, just sending me a note back. Yeah, first time I was in there, I saw the video, or nope, it's still not working. Give me a heads up, and then that way I know that either I'm okay in that area or not. Because this is very frustrating. Yeah. Okay. All right. Besides not being able to see the videos, what else can I help you guys with? You want to look at a long division?
Sure. Yeah.
You want to? Okay. Did I lose? Let's see. Who else still even here?
Still here.
Okay.
There's a lot of
There
people.
you go.
Yeah.
Okay. All right.
I'm just muted
Sweet.
because my house is really noisy.
Oh, girl. This morning, in fact, I've apologized on the first part of the video. If you ever do get to see it in its form right now, my dog was back here snoring, and I'm like, good God. I was like, are you kidding me? So yeah, I mean, just racking them. I'm like, dude. So I was trying to kick her, trying to be nice, but kick her out of the room at the same time. Let me get into 3.3 real quick. And in the notes, you'll notice that I take you through old-timey long division like we used to do in 5th grade. Okay. And what the big change is now, instead of just having numbers, you and I have 2 polynomials. One's trying to divide the other. So, wow, this one's huge. Okay. All right. Well, what I'm looking at is number 2.
Dr. Haas, really quick, for your 3.3 video, is that already uploaded inside the stream?
When I was trying to upload it, and then I realized it was 12:01, so that's why I switched over to y'all. So I don't know if it's uploaded or not, to be honest with you.
Okay, I just making sure. I didn't see it. I just wanted to make sure that it wasn't on my end, that I'm not seeing it.
No,
Okay.
I don't think he's ready to. I think I got notification earlier that he had just processed it, so it's not up there yet. I think the title of it is for it, but it's not processed yet. Does that make sense?
Yes, ma'am.
Okay. So,
Sorry to bother you. I'm sorry.
Oh, no, you're good. You're good. No, my frustration is not with you, believe me. My frustration is just, you try to do some extra stuff and then it's not panning out. And I'm like, golly dang. My house is very much like y'all's. And so I finally figured out the quiet time is from 10 at night to 2 in the morning. So that's when I need to be up doing these. So
Oh my God.
Oh my
yeah,
God.
so that's the part I'm frustrated over. It's okay. All right, so this guy back here in the back, since he's after the division sign, this is called a divisor, okay? And with this divisor, it is easier for you and me in the divisor position to always have all of the terms visible. And so you'll see as you go from x squared down to -3, they flat out forgot that x would have been in there. And so what we call this is a missing term. So when we go to set up our division problem, one of the things I think is very helpful, and it is optional at this point, is to go ahead and put in anything that's missing in the divisor. So it's going to be kind of like you and I are going to be dividing by a 3-digit number. Think of it that way. Okay. So we've got the x squared digit, we've got the 0x digit, and we've got the constant digit. In the numerator, there is, in the, what we call the dividend, in the dividend, we do not have an option here. If you're missing a term, you have to present it to us, okay? Because if you don't, then there won't be a column or what we call a placeholder for it. So you'll notice in this one here that we actually are missing which term?
X squared.
Right. Right here, as he was counting down his powers, 5, 4, 3, and then he went straight to 1. He can't do that in the dividend. He has to go in there and put for us that there's a term missing, so that whenever I place them underneath our division mark here, it'll allow me to have a column to represent that. So I'll have x to the 5th minus 3x to the 4th, 16x to the 3rd, plus 0x squared minus 15x, and let me take him out of my way because I'm going to run into him, and then plus 27. Okay, so it's optional out here in the divisor. If you want to put this middle term, that's your business. I think it helps me. In the dividend, underneath the big square root mark, you have to put that one in because it's representing a certain place value. It's kind of like how I explain it to some of my students. If I said, okay, I'll write you a check for $103, okay, $103, and I write my check this way. Are you going to be cool with that?
No.
You're going to be pissed, aren't you? Because even though, right, there are no tens in $103, you still want it represented, don't you? So in polynomials, we're the same way. When we have to go in there and divide them, I need to see everybody's place value, okay? Think of him that way. So if there's somebody missing, go ahead and put them in as a 0. I also like to put his name. So, whoops, I just lost his name. I'd also like to put his name in here so I know what column it belongs to. All right, so this is a lot easier than a lot of times people make it. When you and I are doing long division in polynomial form, you're going to ask yourself, and you're only going to look at this front term, you're going to ask yourself, what do you have to multiply the x squared by to get the front term, x to the 5th? That's all you care about right now. So what would it take for us to multiply x squared to get x to the 5th power?
X to the 3rd.
Yep. So if I have an x to the 3 power, remember how if the bases are the same under multiplication, we just add the powers. So I would choose an x cubed as my missing factor. That x cubed then goes on top of where the x cubed column has already started. Okay. Now, what we're doing is we're starting the answer. Okay. The answer to this division problem is called the quotient. The quotient will sit upstairs on top of the long division mark.
Can I ask something?
Sure, go for it.
Usually, like when I've gone to some sit sessions for polynomial long division, and from what it looked like, it like coming into this like naively, like it seemed like the x to the 3rd would go over the
x to the 5th.
the x to the 4th.
Oh, yeah. Here's okay. I totally know where you're coming from. So let's go back to something we know how to do. Okay. So if I said I have 122, and I'm going to divide that into 5,376. Okay, something like that.
Mm-hmm.
Then let me tell you that this will I can get 4 groups of 122. Where am I going to put that 4?
4 groups of 122. Under the 7.
Right, he's going to be right here, isn't he?
Yeah. Okay.
Okay.
I
Now,
see what you're
why
saying.
did you put him on top of the 7 and not the 3?
Because when you make 4 groups of 122, it's going to be less than 537 and not less than 53.
Okay. So in this case, like we said, there was a 3-digit number. So you'd have to have 3 digits in order to divide into it. So over here, I have a trinomial, right? That's why I love to put my missing terms in my divisors. And then that tells me that I'm going to have 3 terms to start off with. So that's how I know to put the x cubed where it goes. Plus, another handy tip is he has a 3 as a power. So does the column that you just put it in. It's just a handy tool. Okay. Where do you actually put it? It really is irrelevant, to be honest with you. I like putting my x cubes in my x cubed columns. Then I know that the next time I try, I might have to use a square. Then the next time I try, I might have to use just an x. And the next time I try. So I know after x cubed goes through here, I only have 3 different positions now that I might have to go find.
I see.
Okay. All right, so now that we found this x cubed, what we're going to do is we're going to take the x cubed that we bought this x cubed based on x squared times x cubed would give us x to the 5th. However, you're going to take this x cubed and you're going to times it by your x squared plus 0x minus 3. You're going to distribute x cubed all the way through there, and that is what you and I are going to put right here. So x cubed times x squared would be x to the 5th. X cubed times 0 is still 0. I'm going to put his name as x to the 4th because that's what it would have been. And then negative 3 times x cubed will go right here. And what you'll see in the, hopefully in the video, but also in my notes, but talking to you here is just as good. Let me change colors real quick so I can identify something for you. In long division, back to this 122 divides 5,376. Wouldn't we subtract now at that point? You remember doing long division? Okay. So when we subtract a polynomial, let's look at him. If you subtract a polynomial, this is what I'm having to subtract here in just a second. What does subtracting a polynomial do?
You have to distribute the negative.
Yeah, it's going to change everybody's sign, isn't it? So out here, I know a lot of times, like when I was in school, my teacher would just show me how to change the sign within the sign that was already written, but then you would forget what you had. So this is what I've kind of adopted now. This was a positive x to the 5th. I put a circle around his new sign. 0 is neutral. It won't matter, but I just like to get in good habits. So I'm going to change that to a minus. Minus 3 here has to change to his opposite. So now my new sign is a positive sign. So now I can see what all my new signs are because I'm about to add now the columns together. This is how you'll know you're on the right track, okay? If you and I go back in there and look at the first column, you had better get rid of it. X to the 5th and a negative x to the 5th, that's 0. So I know I'm on the right track. Now I just add up the rest of the columns. Negative 3 and 0 is still negative 3. Let me change my color back. That's still negative 3x to the 4th. Positive 16 plus 3, that's a positive 19. You remember in long division how you would always bring down the next term?
Yeah.
We do the same thing. We do the exact same thing. So we really are mimicking the old long division style. It's just so many people haven't long divided in so long that, you know, they forget how to do it. Let me take some of my work over here out of the way, because we're about to start the game all over again. He now says, okay, you're going to start with that x squared. What can you times him by? To get negative 3x to the 4. So we're back to the front position here. So what's our missing factor?
X squared.
Negative 3 x squared.
That's right. Negative 3x squared is the missing factor that I need. I'm going to go ahead and store that up here in the x squared column even. That way I know I'm right on track. I'm going to take this negative 3x squared that we've chosen, and now I'm going to times him by x squared plus 0x minus 3. That's my divisor. That's the same thing you and I would have done over here. After we did our subtraction in the problem, you and I then would have said, okay, well, how many now do I need to times by 122 to take out whatever's left? We would have done the exact same thing. Here, negative 3x squared times everybody gives us negative 3x to the 4th. That's why we picked it. Gives us a 0x to the 3rd. And negative 3 times negative 3 is a 9 with an x squared on it. Let me move this little guy. Okay. So now, division by definition is repetitive subtraction. So you keep subtracting, keep subtracting, keep subtracting. Well, if we go to subtract this polynomial then, all the signs are going to change again, aren't they? So instead of negative 3, this one's positive. Like I said, 0 is neutral, so it doesn't matter. But then this positive 9 is now negative. And now if we add the terms together, you know you're right if what happens. Negative 3x to the 4th, positive
Cancel out.
3x to the 4th, that's 0. Okay. If it doesn't add up to be 0 in the front position, then you didn't choose the right number. So now I have 19 minus 0, that's 19 in the x cubed column. 0 and negative 9 is minus 9x squared. We've got another term, we're bringing him down. That'll be, whoops, minus 15x's. Let me get my 5th grade problem out of the way. The hard 5th grade problem. Okay, and so now we're going to start it over again. So you have to continue dividing. This one's a very long one. You have to continue dividing this until when you bring down finally this 27 in a little bit, that'll be the last thing you brought down. So it'll be the last thing you and I have to figure out the division for. If we start off with our x squared, what do we need to times it by to make the 19x cubed?
Uh, 19x, yeah.
19x, right? And since it's 19x, that means it's a positive 19x. We didn't say anything about it being negative, so it's assumed to be positive. I'll go up to the x column. That's where I'll store it. I'm going to now take that 19x and I'm going to do my work with it. Oops. And all that means here is that I'm going to now time, maybe not, I'm going to times it by my divisor again. So 19x times everybody gives me 19x to the 3rd, 0x squared, and this last one here would be, what is that, negative 57, I think. You might want to check me on that. I think that's right, negative 57 x's. Subtraction is built in, so we know this 19 was positive. Let's make him negative. 0 is neutral. 57 is negative, so let's make him positive. If the leading terms of both of those add up to be 0, we're right on track. Did it happen? 19 and negative 19 are gone. So negative 9 and 0 is still negative 9 in the x squared column. Negative 57 and negative 15 and positive 57 is what? Positive 42. We'll bring down our last term, and we have just one more to do. So the larger or the higher the degree power on your dividend, the more steps it'll take you to long divide. I can give you a long division problem that takes 2 steps. I don't have to drag this thing out until tomorrow, okay? So I can definitely judge how many steps it's going to take by the type of problem I give to you. This last one here, how in the world would we take an x squared? Again, I'm just focusing in on the first term of the divisor. What can we times it by to give it us negative 9x squared? And what would my mystery multiplier have to be here?
Negative 9.
Yep. So I know I'm going to be finished with the quotient. This is called the quotient up here. We usually use like Q of X. That's our quotient. I still have to go through the mechanics of everything. I'm going to multiply my divisor now by negative 9. So I'll go back and x squared plus 0x minus 3. All of this over here on the left-hand side is usually done mentally, but I need to show you what's happening. And so, I mean, I would expect to see it from you. Negative 9 times negative 3 is a positive 27. Oh, this one's going to be cool. Let's see what happens. Set up subtraction. And so that means this becomes a positive 9. 0 is neutral, and this becomes a negative 27. If the first term of each one of those polynomials now cancels out to be 0, it does. It looks like I'm left with, what, 42 x's? Because 27 and negative 27 is 0. So this is what we would refer to as the remainder. We write R of x because now that we're in polynomials, your remainder might be a constant or it might be a polynomial. So 42x is what we call the remainder. This one was a beef of a problem, but it is the one that I read off of my homework that they generated for me for number 2. So do expect to see something probably as high as to the 5th power, just one time on the homework. The nice thing, go ahead.
Can you explain the changes of the signs again?
Sure. Go back to what we know about when we do division also. When you divide, let's say 25 into 133, then we would say that that's going to be, you think I would pick something I would know. I think that is 5. So 5 times 25 is 125. And so what do we do in long division?
Subtract.
Right. Now this is going to sound like a really stupid question on my end, so please bear with me. When we say we're going to subtract, right? We subtract the ones column, right?
Yes.
We subtract the tens column and we subtract the hundreds column. We don't think like that, but that's literally what we're doing. Up here, whenever we have the subtraction, let's say for this last step right here, because my terms are split away from each other with a plus sign or a minus sign, you literally have to distribute the idea of subtracting all the way across. So if you're trying to subtract a negative number, that's why it becomes positive. Here 0 is neutral, so it doesn't really matter. Here this was plus 27, but according to division, I have to subtract. So when I subtract a positive, it turns to be a negative number. It literally changes everybody's, meaning every term sign all the way through your polynomial.
Okay.
Does that help at all?
Yes.
Okay. We would look creepy Okay, right. We would look creepy if we said, I'm going to do 3 minus 5 and 3 minus 2. And we would look creepy if we did that. But honest to goodness, that's what we're doing. We just don't write the sign at every place value. Here, I don't have a choice because this 9x squared is one term. This 0x is a different term, and the 27 is a different term. So that's why I have to show I'm subtracting all of them.
Okay.
You know, by far, that is the hardest part, I think. A lot of people get the idea of how to get started, but a lot of people will mess up on signs, definitely. Just remember, you're having to subtract everything that you just built. So if it was positive, it's now negative. If it was negative, it's now positive.
Okay.
Okay. All right. Well, maybe that'll get you started at least. Please don't blow off the two first problems in 3.3 in the notes that talk about just how do we long divide in general, because I kind of talked you through it on the video. If you look at the notes that I've already filled in for you, I think you'll be able to follow it fairly well. One thing on the video is I ran out of room to write at the very bottom of one of the examples. And so I did tell you in the video to refer to the filled in version because you will see it all filled in there. Okay. I'll work on the videos and see what the heck I can do to get this more friendly to use. Those of you who don't have any problems at all, that's great. Just hang tight there. What I'll probably do is I'll just open up another page in our modules in that chapter, and I may just load up all the other links in there instead. So I'm not going to take anything off. I'll just put, here are some alternate ways to get to the videos or something like that for you. Okay?
Okay.
Okay.
All right. Again, as always, please feel free to holler at me. I know this weekend is our Good Friday and Easter, so I know you may have other things to do too. Try to get as much work as you can done, though, before I see you Thursday. And I will try to have things fixed for Thursday for you.
Thank you.
You bet. You bet.
Thank
All
you.
right,
Thank you for your patience.
Oh, absolutely.
Yeah.
And thank you for y'all too, because like I said,
Take a picture of this screen.
my intentions are great. I promise you they are. And man, you talk about a letdown after, the work that you put into it. If it's not doing what you want it to do, it's just really a kick in the pants. So I will, like I said, I will go back in there and do what I need to do. Okay.
Okay. Thank you
Okay,
so
thank
much.
you.
All right.
Appreciate
You
it.
bet. All right. I'll see y'all on Thursday then.
All right. Bye-bye.
Bye now.
See ya.
Bye. See ya.